Hi, I would like to work out some formulas for the integrals of some trig functions. I say some because there's like all sorts of different ways that we could combine trig functions to get different things, and we're just going to limit ourselves to some basic kinds of formulas for trig functions. I'm going to work from what I know, and what I know are derivatives. When I took my when I took my derivatives test, my applications of derivatives test, I had a little cheat sheet I made. It's coming in super handy right now as I work on mastering integration. Here's what I've found in my notes on derivatives for integration. I had this. I observed the following: that sine, when I take the derivative, goes to cosine, and then when I take the derivative of cosine, I get minus sine, and when I take the derivative of minus sine, I get minus cosine, and when I take the derivative of minus cosine, I get positive sine back. This is really cool length for a cycle when I take the derivatives, right? So following this arrow is taking d dx. d dx. Sure, it's fine. It says d dx, I promise. Okay. So differentiation walks in a circle like this, and I know that integration is undoing differentiation because we're finding antiderivatives. And antiderivatives are functions where I take the derivative and get my original thing back. Okay. What this means is that the thing at the end of the arrow is an antiderivative for the thing at the beginning of the arrow. So that means that cosine is antiderivative to sine. So I can walk in this direction and integrate. Okay. That means that the integral of cosine is sine. Plus c, always plus c. And let's see here. So I did cosine here, so we should do the integral of sine of x dx. Let's see here. So I start at sine, and then I'm going to walk the arrows. I'm going to walk the differentiation arrows backwards, or the integration arrows forwards, and I'm going to go to minus cosine of x plus c. And then I could put minus signs and do like all four of these arrows, but it's enough to do these because multiplicative constants pull out. And so the integral of minus cosine is minus sine. The integral of minus sine is positive cosine. I'm not going to write those two things down because we get those for free with by like multiplying by minus sign on both sides and then pushing the minus sign into the integrand. Okay. I kind of want to bring in the other trig functions at this point here. So like sine, cosine, fine. What about secant and tangent? Secant, tangent, cosecant, and cotangent. Where are those in this whole game? Well, I'm working based off of derivatives that I know, okay? Because those are going to be my keys to the world of integration, because anti-differentiation is the fundamental step in doing both indefinite and definite integrals. So I'm going to write down my differentiation rules that I remember. I remember that d dx of tangent of x is equal to, let's see here, the derivative of tangent is equal to, this one was equal to secant squared. d dx of secant of x is equal to secant of x tangent of x. d dx of cotangent of x is equal to minus cosecant of x with a squared, and d dx of the cosecant of x is equal to minus cosecant cotangent. Now I kind of remember those. Well, so like I've got like a cheat sheet here, right? Like, but I've got my. I think it's fine if you still need references for these things. I mean, you should totally memorize them, but like use aids, you know. Okay, so the C's get minus signs, and that's what I remember. Okay, what this means is that I can integrate and go in the other direction. So I get 4 more rules for integration based on this table. This means that the integral of secant squared of x dx is equal to tangent of x plus our friend c. That the integral of secant of x times tangent of x dx is equal to secant of x plus c. And then the other two, the integral of minus cosecant squared of x dx is equal to cotangent of x plus our friend c. And finally, I think this is probably getting a bit repetitive for some of you, minus cosecant of x cotangent of x dx is equal to cosecant of x plus c. I remember these literally by remembering the differentiation formulas. And I wouldn't be surprised if it was that way for other people too. Of course, I only know my own mind, and I can't read anybody else's. But I'm pretty sure that remembering these gives the keys to these. So go backwards. So thank you so much for watching, and we'll continue to build on these basic rules to do more and more complicated integrals as we move forward. Thank you.